In this video, we're going to talk about ratios, rates, and proportions, and it's mostly made as a review for geometry. All right, so let's start with ratios. Okay, you probably remember that a ratio is the quotient of a number b, where b cannot be zero. Okay, this provides a comparison between the numbers a and b. Right, since every division or every fraction indicates a division, then every fraction that you have wrote before is basically a ratio because it's comparing two quantities. We read this as a to b. All right, and another way of writing this usually is a to b. All right, so remember, we read it as a to b because we're comparing two quantities. Also, we call this number a, we call it the antecedent. And this number b, we call it the consequent. All right. It's generally preferable to express a ratio in simplified form. So if we're comparing these two quantities, for example, 6 compared to 8, okay, it's a good practice that we give this in simplified form. We notice that we can simplify both numbers by 2, for example, right? So we can rewrite this. We can rewrite this ratio as 6 divided by 2 is 3 and 8 divided by 2 is 4, right? So we can rewrite the ratio as 3 to 4. We can also write it as 3 to 4. So we can write it with the columns. Let's try to make more comparisons in between numbers. Let's suppose that we want to compare 12 to 20, all right? We can write this as 12 over 20 or 12 to 20, and we can simplify it. Clearly, we can simplify both numbers by 2. Let's try by 2. Right? Let's try by 2, and we will get that 12 divided by 2 is 6, and 20 divided by 2 is 10. But you notice now that you can simplify a little bit further, right? So you can divide again by 2 if you want, because you notice that both are divisible by 2 again. So 6 divided by 2 will be 3, and 10 divided by 2 will be 5. You probably notice that you don't have to do this to simplifications. Again, let's do it again. 12 divided by 20. We immediately notice that both are divisible by 4. So we divide it by 4. And 12 divided by 4 will be 3, and 20 divided by 4 will be 5. And this is the preferable method that you can use to simplify two ratios. Okay, when we're simplifying a ratio of two quantities that are expressed in the same unit, we are going to eliminate, or we're going to cross out the common unit. So if we're trying to compare, for example, let's suppose that we're trying to compare 12 inches, we're going to compare it with 24 inches. Right? We immediately notice that these two quantities are the same, so we are comparing the two, and we can cross out this 2, and we get 12 to 24. And we can simplify both. We noted that both are divisible by 12, so we can divide by 12 on both sides. 12 divided by 12 will be 1, and 24 divided by 2 will be 2. So the ratio of 12 inches to 24 inches is 1 to 2. Right? Basically, we will have 1 inch for every 2 inches. That is basically the idea. What will happen if we try to compare 12 inches and 3 feet? What will happen in this case? Notice that the two units seems or are different. Right? This is inches, this is feet, but both are units of length. And we know that we can convert feet to inches because we know that for every 1 feet, we have 12 inches, right? So we can rewrite this ratio as 12 inches to 3 feet. So 3 times 12 is 36 inches. So 3 feet is 36 inches. And now we can do the simplification. So this 2 will be crossed out, right? And we will have that, let's do it right here. We will have that 12 is going to be compared to 36. Can we simplify now? Yes, we can simplify by 12, right? 12 divided by 12 is 1, and 36 divided by 12 will be 3. So this will be our ratio for this comparison. When we have different units, we might have a different story. For example, let's suppose that we're trying to compare, let me do it with a different color. Maybe we're trying to compare 5 pounds to 2 feet, What is the problem with this? When we have these two quantities like this, they cannot be compared because they have no common unit of measure in between, right? So this is basically weight and this is basically length. So we cannot compare the two. And when this happens, we call them that the quantities are said to be incommensurable, all right? So we cannot deal with these two comparisons as we did before, all right? Not as a ratio. But for this type of quantities, we have what we know as a rate, right? A rate. A rate is a quotient that relates to quantities that are incommensurable. Okay, so let's suppose that almost every person has a vehicle or is familiar with how vehicles work. All right, so maybe we have a car or a motorcycle or something like that, and we know that for every 200 miles, right, we consume 5 gallons of gasoline, of gas, right? For every 200 miles, we consume 5 gallons of gasoline. For every 5 gallons of gasoline, I can only drive the car for 200 miles. Okay, so this is a comparison in between two quantities that are incommensurable. Now, can we simplify it as we did before? Yes, we can, and it's a good practice. If you notice, we can divide both quantities by 5, right? By 5. 12 divided by 5 is going to be 40, so 40 miles. We're not going to cross out any units here. 5 gallons divided by 5, so 5 divided by 5 is 1 gallon. So what I just found with this rate is that for every 40 miles, we're going to consume 1 gallon of gas, right? So this is how it works. This is how rate works. It's pretty common that we say that 40 miles per gallon, right? We can drive the car for 40 miles per gallon. We can compare other things. For example, let's suppose that I will spend, if I go to the gas station, I'll get for 18 bucks, I will get, let's suppose that I'll get 4 gallons of gas. All right, for 18 bucks, I get 4 gallons of gas. And this is also a rate. Can I simplify this rate? Yes, I can simplify this rate by 2, for example, by 2. And this will tell me that for every 9 bucks, then I will be able to get 2 gallons of gas. So I can say like, all right, this is not telling me much. Like 18 bucks for 4 gallons is exactly the same as 9 bucks for 2 gallons. But then we can use what we call a unit rate. We use a unit rate when we aim for this value to get equal to 1. So if we divide by 4 here, we will know that we're talking about 1 gallon of gas. So we will also divide 18 by 4, right? And we will get that 18 divided by 4, it's 4.9 bucks, right? Dollars. Divided by 4 is 1 gallon. So what this is saying is, let me rewrite it properly. So 4.5. What this is saying is that for every gallon, right, I have to pay 4.5 bucks. Or if I have $4.5, I can buy 1 gallon. Okay, this is basically a rate. This is how rates work. All right, another thing that we need to discuss are proportions. So proportions. So a proportion, it's basically this equality. When we have one ratio, like A to B, equal to another ratio, C over D, for example. So we have an equality in between two ratios, okay? So when we make an equality in between two rates or in between two ratios, we have what we call a proportion. We can remember that we can rewrite this also as A to B, it's equal to C to D, right? These two are called the extremes, right? And these two are called the means, okay? These are the means. If we look at here, then the extremes will be these two, right? And the means will be these two, okay? So means and extremes, okay? In the two versions. Let me separate this so you can see it better. All right, so that's how we name them. Okay, we can come up with a property from this. That property is called the means extremes property. And what it states, it's also known as the cross product property sometimes, but what it states is that if you have a ratio like this, A to B, it's equal to C to D, you can check if the ratio is true if we get that A times D, so if you multiply the extremes and you get that this product is equal to multiply the two means. So B times C. All right, what we did is basically this. A times D, this part, it's equal to B times C, this part. If we check that this is true, obviously B and D cannot be zero as we stated before. If we know that this is true, then we know that this is a proportion, okay? Let's do an example. Let's suppose that we have 9 to 12. It's equal to 2 to 3. Okay, how can we check if this is true or not? If we multiply, again, remember, extremes and means. So if we multiply the extremes, so if we multiply this to 9 times 3 must be equal to the multiplication of the means. So the multiplication of this 2, right? 12 times 2. Let's see, 9 times 3, it's 27. But 12 times 2 is 24. Since it's not equal, then this is not a proportion, right? It is not a proportion. Understood? What if we change it? What if maybe we don't have this? Maybe we don't have this. Let me erase all this. Maybe we made a mistake. And maybe what we have is this. Maybe we have 9 to 12. It's equal to 3 to 4. All right? And we check again and we multiply 9 times 4. 9 times 4 must be equal to the multiplication of the string, 12 times 3. Right? But we know that 9 times 4 is 36. We know that 12 times 3 is 36. So, oh, wow, yes. This is a proportion. It's a proportion. All right? So that's how we check. This property is really useful when we are trying to solve proportion in which we don't know one of the values in it. So let's try to solve one of those examples. This is really common in geometry. So x compared to 8, it's equal to 5 compared to 12. So we don't know the value for x, but we have that cross product, that means extremes property. So we know that we can multiply this to 12 times x is 12x, right? And this is going to be equal to the multiplication of the streams, these two, 8 times 5. 8 times 5 is 40, right? Can we solve this equation? Yes, remember that if you're multiplying by 12, you apply inverse operations on both sides. You get rid of this 12, and now you are isolating for x. So x is going to be equal to 40 divided by 12. And 40 divided by 12 can be simplified. So we can divide by 4, both numbers. 40 divided by 4 is 10. And 12 divided by 4 is going to be 3, right? So x is going to be, or it needs to be equal to 10 over 3 to be able to have a proportion. That will be the value to make this a proportion, right? X is equal to 10 over 3. You can even divide that. 10 divided by 3, it goes 3 times. This is 1. You add a 0, right? And you know that it's going to be 3, 3, 3, 3, 3. So x, another way of writing this will be that x will be equal to 3, 3, 3, 3, and so on. That's how you deal with the means extremes property. Let's do one more example. Let's suppose that we have something like this. 3 over x is equal to x over 2. And you probably remember this from your studies of algebra. Again, you can multiply this proportion. So 3 times 2 is 6, right? And this is going to be equal to the multiplication of the extreme. So x times x is x squared. All right, so let me rewrite this here. So we have x2, it's equal to 6. All right, so remember that this is a quadratic equation, and we know that the power of 2 or the square, the inverse operation of this, is the square root. So we can apply the square root of both sides, right? But we need to remember that if we apply the square root of this side, it could be positive or negative. Remember that. You need to remember this from your studies of algebra. This will be crossed out, and we will get that x is going to be equal to positive or negative the square root of 6. Right? It's going to be really common that since in geometry we study length or distances or always we're dealing with positive values, we are always usually in geometry we're going to get rid of that negative and we're going to use the positive value. So we will probably use only the square root of 6. This is really common in geometry. We can even use it with the decimal representation of this that is around 2.45, right? All right, so that's how you deal with this. Let's do another one. What if we have x plus 3 over 3, it's equal to 9 over x minus 3. So remember that we basically multiply as a cross. That's why it's also called a cross product. So x plus 3 is going to be multiplied by x minus 3. And this is going to be equal to this multiplication. So remember, we multiplied this first, now we'll multiply the other. 3 times 9 is going to be equal to 27, right? If you remember again from algebra, this is a difference of squares. So you can rewrite this as x2 minus 3 to the power of 2, right? And this is equal to 27. 3 to the power of 2 is 9, so we will have x2 minus 9 equal to 27. And since we have a simple quadratic equation, remember that we try to isolate x, right? So to isolate x, we can do it adding 9 on both sides, right? So these two are gone, and we will have that 27 plus 9, it's x2 is going to be equal to 27 plus 9, that is going to be 36, right? We know that the inverse operation of x2 will be the square root. And remember that we know that this must be positive and negative. Let me put the equal sign again. So these two will cross out. So x will be equal to positive or negative the square root of 36, that is 6. So we will have two answers. X will be equal to 6 or x could be equal to negative 6. That will be our possible solution for this. Remember, if we're solving problems with geometry, it's going to be really common that we only use the positive answer. Okay, just a heads up, remember that not all quadratic equations are solved like this. It's really common that you use factoring methods for trinomials or that you use the quadratic formula. So you can review that in another video. Now, let's do a problem. So we have this problem. A car can travel 90 miles on 4 gallons of gas. How far can it travel on 5 gallons of gasoline? So basically, we have a proportion problem. 90 miles, it's compared to 4 gallons. So we have this rate, 90 miles to 4 gallons, all right? So we can compare this to, all right, so what I want to know is if I can run my car for 90 miles with 4 gallons of gas, right, for how many miles, so how many miles I can run the car if I put 5 gallons in it, right? This is what I'm looking for. This is what I'm doing, right? And since we have this small equation, we can apply the means and extremes property. Okay, so let me move this real quick here. And what we're going to do is just solve this proportion using the cross product. So 90 miles times 5 will be equal, let me do it here, to 450 miles per gallon, right? And it's going to be equal to this too, 4 gallons times x, 4 gallons times x. Notice that I'm leaving the units so you know what's going on with the units. To isolate x, we need to divide by 4 gallons, right? So we divide by 4 gallons on both sides, right? In this case, these two cross out. These gallons are going to cross out also, right? So we can divide this. We can divide 450 divided by 4 real quick. So it goes one time. Negative 4 is 0. You bring the 5 down. It goes one time again. 1 times 4 is 4. So 1. You bring the 0 down. It goes 2 times. It's 8. And 10 minus 8 is 2. You bring the 0 down. And it goes, we put the decimal point and it goes 5 times. 5 times 4 is 20. 220 is 0. All right. So it's going to be 112.5. So 112.5. Since we cross out the gallons, we're left with miles. So 112.5 miles, it's equal to x. So this value that we just get here is the amount of miles that we can run on a 5 gallon of gasoline, right? So remember, we were looking for, if I know that I can run my gas for 90 miles per 4 gallons, how many miles can I run the car for 5 gallons? If we do the proportions, applying the cross product property, we know that that value will be 112.5 miles. You don't have to write the units like this. You will probably learn, and if you did it with me as your teacher, you probably learned it. Like, you don't have to write the units. You need to be really careful on what are you looking for. You're looking for miles, so you don't have to write the units. At the end, you know that you are finding miles. All right. For ratios, we also have something that is called the property of extended ratios. So the property of extended ratios. So what this property states is that an extended ratio compares more than two quantities and must be expressed in such a form as A compared to B compared to C, or even compared with more quantities, like compared to D, whatever. All right. So if we have something like this, A to B to C, let's do it with an example on geometry. Let's suppose that we have a triangle in which the angles are 90 degrees, 60 degrees, and 30 degrees. This is a common triangle in geometry, right? The 30, 60, 90 degrees triangle. So if we have this, we can write this extended ratio, 90 to 60 to 30. And we can even simplify. We notice that we can simplify everything by 30, right? We can simplify this by 30. We can simplify this by 30. We can simplify this by 30. So we can rewrite it like this. 90 divided by 30 is 3. 60 divided by 30 is 2. And 30 divided by 30 is 1. So we have a ratio, an extended ratio of 3 to 1. Okay, so in this type of triangles, with 90, 60, and 30 degree angles, if we compare the quantities, we get that the ratio is 3 to 2 to 1. Okay, and we can use it to solve some problems. So let's solve a problem. All right, so we have this problem. The perimeter of a quadrilateral is 140. And the length of the sides are in the ratio 2, 3, 4, 5. Find the measure of each side. So what this is telling me, if maybe we have a quadrilateral like this, right? Maybe let's suppose that it's something like that. All right. All right. So what this is telling me is that the size, the smallest size, will be 2 times the unknown quantity. But the next size must be 3 times that quantity, so 3x. And the next side will be 4 times that unknown quantity. And the fourth side will be 5x, right? Because it's in the ratio 2, 3, 4, 5, and we don't know the real measure of the quadrilateral. To find the perimeter, we add all these quantities. So 2x plus 3x plus 4x plus 5x must be equal to the perimeter given, so 140, right? We know that these are like terms. So 2 plus 3 is 5, plus 4 is 9, plus 5 is 14. So 14x, it's equal to 140. We know that to solve this equation, we can divide on both sides by 14. This 2 will be crossed out. So x is going to be equal to 140 divided by 14. That is 10. So we know that the value of x is 10. If the value of x is 10, 2 times 10 is 20. So this side will measure 20. 3 times 10 will be 30. The measure of this side will be 30. This will be 40. This will be 50. So of course, if this is the ratio for our quadrilateral, then our sides must be 20, 30, 40, and 50 to get the initial perimeter. All right. So that's how we deal with ratios and rates and proportions in geometry. Let's do one last problem. All right. So in this problem, we have two triangles. In these two triangles, this proportion, it's true, right? So MP to AC is equal to PN to CB. So what it's saying is that MP is to AC as PN is to CB, as MN is to AB, and I need to find the measure of CB and AB. Right? To find it, I'm going to, so I don't have to write all this notation for segments. I'm going to call this X, and I'm going to call this Y. Okay, so basically we're looking for X and we're looking for Y. Okay, we know that these proportions are true. They are given. We know that are true in this triangle. So, okay, so we can substitute in this proportion and we get that MP is 4. So 4 is to AC, AC is 10, right? 10, equal to PN, PN is 5, so I change it by 5, over CB to CB, CB is Y, I don't know why, right? It's going to be equal to MN, MN is 6, compared to AB, AB is X. So we have this proportion. To solve this proportion, we can group, to find the value of Y, for example, we can group this proportion and we can solve it, right? Y, if we apply cross product, 4 times Y, or Y times 4 is 4Y, equal 10 times 5 is 50. We can divide on both sides by 4. This will be crossed out and we get that Y, it's equal to 12.5, right? If you divide 50 by 4, you get that Y is going to be 12.5. So we know that this Y is 12.5, right? Now, how can we solve the other proportion? Well, we know since everything is equal, we can use this equal to this, right? So we can write this proportion, the next proportion, 4 to 10, it's equal to 6 to X. And we can apply the same method. So 4 times X is 4X. 10 times 6 is 60. We divide by 4 on both sides. This is gone, and we get that X is equal to 15. So we know that X is going to be equal to 15. What will be the values for CB? Well, CB is 12.5, so this will be 12.5, right? And AB will be 15, so AB will be 15. And this is the measure on how we can use proportions. So this is how you can use proportions. In this case, the proportion was given, right, to find values in another triangle if we know that the proportion is true. Okay, so this is just a quick review. Maybe we are dealing with a lot of information. I hope that is useful for you, since we're going to use a lot of these concepts to learn about similarities in triangles. All right, see you in the next video.